Namaste. Welcome to balancing chemical equation by using algebraic method. In this video, we are going to learn about how to balance chemical equation using algebraic method. The method is bit lengthy, but once you practice and master over that, I definitely promise you that you will enjoy the method and you need not have to cram down the coefficients for balancing equation. So practice this method very well over the number of equations and success will be there definitely. So let me have the first equation to balance, that is action of heat on lead nitrate. So I have a lead nitrate PbNO3 twice. When heated, it decomposes to give me lead oxide plus nitrogen dioxide plus oxygen gas. Now I need to balance this equation. So I have to assume some coefficient here. So let me assume a coefficients for this here as a for PbNO3 twice, B for PbO, C for NO2 and D for O2. Now my job is to find out the values of this ABCD. So first of all, I'll write down for PB. So PB is equal to, now A into PB. So I'll get here A. Now do remember the arrow which is present here, that is replaced with equal to sign. That is replaced here with equal to sign. Now where the PB will be there, that we need to find out. So it is B into PB. So I'll just simply write here B. Then I can write down for nitrogen. So nitrogen is equal to, here nitrogen is multiplied by 2. So I'll get 2 nitrogen and that is multiplied by A. So I'll get here 2A. Then once again the arrow is there, that I replace with equal to sign. Where the nitrogen is there, here. So it is equal to C. So 2A is equal to C. Then I'll write down for oxygen atom. Then I'll write down for oxygen atom. Now oxygen, I have 3 2s are 6 oxygen and that is multiplied with A. So I'll get here 6A is equal to B into O. So I'll write simply here B. Then here O2 into C. So I'll write here as an plus 2C. Whatever the plus sign is there, that will come as it is. That does not undergo any kind of change. Plus, I'll get here 2D. I'll get here 2D. Okay, so this oxygen is multiplied by 2D. So I'll write down that as in 2D. Now my job is to find out the values of this ABCD. The values of this ABCD. So let me assume, let A is equal to 1. So if A is equal to 1, I'll get B also equal to 1. Okay, so then I'll find out the value of C. Now 2A is equal to C. A just now I assume 1. So C I'll get it as in 2. Now after getting the values of A, B and C, let me substitute these values of A, B and C in this equation and try to find the value of D. So I will have here 6 into 1 is equal to 1 plus 2. C value I got it as in 2 plus 2D. So 6 is equal to 5 plus 2D. So D I'll be getting as in half. D I'll be getting as a half. Now after getting the values of A, B, C and D, let us substitute this value in the equation. So A is equal to 1. So I'll write down here 1 upon 1 PbNO3 twice. I'll write here 1 upon 1 PbNO3 twice, which gives me B. So B value also I'll write down 1 upon 1 PbO plus C value I got it as in 2. So that I'll write down as in 2 upon 1 NO2 plus D value I got it as in half. So I'll write down 1 upon 2 O2. Now if you carefully look at here, the common LCM is 2. If you carefully look at the common LCM is 2. So we have take out LCM as 2. So I'll multiply here by 2, here by 2, here by 2, and here by 1. Okay. So the equation now becomes 2 into 1. So I'll get 2 PbNO3 twice, which gives me 2 into 1, 2 PbO, plus 2 into 2, 4 NO2, plus 1 into 1, that is 1 O2. Now if you carefully look at this equation, becomes now balanced chemical equation. How I can check that? See, on the reactant side I have 2 Pb, on the product side I have 2 Pb. On the reactant side I am having 2 into 2, 4 nitrogen, I have 4 nitrogen here. Okay, then on the reactant side I have 3 2s are 6, 6 2s are 12 oxygen atom on reactant side. Now product side, let me check, 2 oxygen here, 8 oxygen here, and 2 oxygen here. So 2 plus 8 plus 2, 12. So I observe that the number of atoms on reactant side is equal to number of atoms on the product side. So this is balanced chemical equation. This is balanced chemical equation. See, as I already told you, this method seems to be little bit lengthy, but go on practicing this on a number of equations, will definitely enjoy. Now let me take another example to understand this further more clearly. So I have a copper react with HNO3 in order to give me CuNO3 twice plus NO2 plus H2O. NO2 plus H2O. Now once again I'll assume here some coefficient. So let me take this as an A, this is in B, this is in C, this is in D, and this is in E. Okay. Now we'll try to find the values of this coefficient. So first of all I'll write down for copper A is equal to C. A is equal to C. Then write down here for hydrogen H. So B is equal to 2E. B is equal to 2E because here there is a hydrogen. So B into 2E. Then I'll write down further for nitrogen. Let me take another element, that's nitrogen. So nitrogen is here. So B, arrow is there, that I replace with equal to sign. This is 2 into nitrogen into C, that is 2C, plus I have D into N, that is I'll write simply D here, and then I'll find out for oxygen atom. So oxygen, I have 3B. Okay, I have 3B is equal to 3 2s are 6 into C, 6C, plus 2 into D, 2D, plus E. Okay, so oxygen I am having on reactant side at one place, but in product side I am having at 3 places. Now as our normal job, what we do here, by substituting the various values, I need to find out the maximum. So let me assume here, let B is equal to 1. So if I assume here, let B is equal to 1, so I'll have B is equal to 2E. So E will become 1 upon 2. E will become 1 upon 2. Then I have B is equal to 2C plus D. So 1 is equal to 2C plus D. 1 minus 2C is equal to D. Now substituting these values of B, E and D in the third equation, substituting this value of B, E and D in the equation here. So I have 3B, so 3 into 1 is equal to 6C, I don't know the value here, plus 2 into D, D value is 1 minus 2C, and E value I got it as an half. I got it as an half. So let me solve this equation here. 3 is equal to 6c plus 2 minus 4c plus 1 upon 2. Now let me take a common LCM here. Okay, so I'll get here 3 into 2, that is 6, is equal to 12c plus, here there is a common LCM which we take it as an here 2, and here 1. Okay, so I'll be having here 6 to the 12c plus 4 minus 4 to the 8c plus 1. Okay, so I'll get here 6 is equal to 12c minus 8c plus 5. So 6 minus 5 is equal to 4c. 6 minus 5 is equal to 4c. So c value I'll get it as an 1 upon 4. C value I'll get it as an 1 upon 4. Now as C value is 1 upon 4, A value also 1 upon 4, because A is equal to C, so A is also 1 upon 4. Now let me find the value of D. Now D I took it as an 1 minus 2C. So this is 1 minus 2 into 1 upon 4. So it is 4 minus 2 upon 4. This 2 upon 4, I'll get 1 upon 2. Now I got all the values. A is equal to 1 upon 4, B I assume as in 1, C as in 1 upon 4, D as in 1 upon 2, and E I got it here. Okay, so we get it that as in 1 upon 2 further. Okay, now let me substitute the values over here. D already I got it 1 upon 2. Okay, so let me substitute these values of A, B, C, D. So here I have A value as in 1 upon 4, B value as in 1, C value as in 1 upon 4, D value as in half here, and E value as 1 upon 2. So let me substitute these values here. A is equal to 1 upon 4. So 1 upon 4 Cu plus B value I assume as in 1. So 1 upon 1 HNO3. That gives me once again C HNO3. So I'll getting here as in 1 upon 4 CuNO3 twice. Okay, plus 1 upon 2 NO2 plus 1 upon 2 H2O. Now if you carefully look at the common LCM which comes as in 4, common LCM which comes as in 4. So this I multiply by 1, this I multiply by 4, this I multiply by 1, this I multiply by 2, this I multiply by 2. Because LCM here is 4. LCM here is 4. Now let me move further. Okay, so 1 into 1, 1. I'll just simply write that as in Cu plus 1 into 4, sorry, 4 into 1, that is 4 HNO3, which gives me 1 into 1 CuNO3 twice plus 2 into 1 2 NO2 plus 2 into 1 2 H2O. Now let us try to look out for the atoms which are present on reactant side and the product side. So whether it is balanced or not. I have 1 copper on reactant side, I have got 1 copper on product side. 4 hydrogen on reactant side, so 4 hydrogen on product side. 4 nitrogen on the reactant side, 2 nitrogen here and 2 nitrogen here. So 4 nitrogen on product side also, 2 nitrogen with copper nitrate and 2 nitrogen with NO2. Okay, now hydrogen, 4 3s are 12, sorry, oxygen, 4 3s are 12 oxygen. So I have 3 to the 6 here oxygen plus 2 to the 4 and 2 oxygen with water. So 3 to the 6, 6 plus 2 4, sorry 6 plus this is 3 to the 6, 6 plus 4 10 and 10 plus 2 12. So here I got, once again, this is a balanced chemical equation. This is balanced chemical equation. Okay, now let us move further to understand one more equation in this way. Now we'll move a little bit faster because we know the process. Now let me take one more equation here. So I have equation that is your S plus HNO3, that's nitric acid concentrated, gives me H2SO4 plus NO2 plus H2O. So let me assume once again a coefficient here. So I get here A, B, C, D and E. So let me write down the values for this. So sulfur, I have A is equal to C. Then I have a nitrogen, that is B is equal to D. You know the process now. We do rapidly. Okay. Then I have a hydrogen. So hydrogen I can write down B is equal to 2C plus 2E. And then I have oxygen. I'll be writing here 3B is equal to 4C plus 2D plus E. So S into A, so I'll write A. Then here I have a sulfur. So like this way you try to find out the coefficient values and we get the equation. Now I'll assume first here, let B is equal to 1. So B is equal to 1, D also will become 1. Okay, and then I have 1 is equal to 2C plus 2E. So I'll get 1 minus 2C is equal to 2E. So E is equal to 1 minus 2C upon 2. So I got here value of B, I got value of D, I got value of E. So let me substitute in this particular equation. I have 3B is equal to 4C plus 2D plus E. So I got values of B, D and E. So I am substituting. B value as in 1. So 3 into 1 is equal to 4C. C value I don't know. Plus 2. D value I got it as in 1. Plus E value I got it as in 1 minus 2C upon 2. Nothing, everywhere you assume 1 here as an denominator. Now I got in common LCM here as a 2, here as a 2 and here as in cross multiply. When we do that, we'll get 2 here. So I have here the further equation, which will be 6 is equal to 8C plus 4 plus 1 minus 2C. Okay, so I get here 6 minus 5 is equal to 6C. So C is equal to 1 upon 6. C is equal to 1 upon 6. Now A and C are equal, so I'll get A also equal to 1 upon 6. A also equal to 1 upon 6. Now let me have the value of E to be found out. Now E value is 1 minus 2C upon 2. Let me find out the value of E here. So I have E is equal to 1 minus 2C upon 2. C value I got it as in 1 upon 6. So I'll simplify here further. 1 minus 2 into 1 upon 6 whole upon 2. So this will be 6 minus 2 upon 6 upon 2. So I'll get here 4 upon 6 into 1 upon 2. So I'll get here E value as 1 upon 3 after solving this particular equation. Okay, so I have the values of A, B, C, D and E with me. So let me substitute here. I have A value 1 upon 6 as an S plus B value as an 1 upon 1 HNO3. That gives me here C H2SO4. So C value as in 1 upon 6 H2SO4 plus D, that value I got it 1 upon 1 NO2 plus E value I got it as in 1 upon 3 H2O. 1 upon 3 H2O. So let me have here a common LCM as in 6. So common LCM here as in 6. So here I'll multiply by 1, here I'll multiply by 6, here I'll multiply by 1, here I'll multiply by 6, here I'll multiply by 2. Okay, so in order to get common LCM, so 1 into 1, 1 plus 6 into 1, 6 HNO3, which gives me 1 into 1, 1 H2SO4, so 1 normally we don't write, plus 6 into 1, 6 NO2 plus 2 into 1, 2H2O. Okay, now we try to see the number of atoms on reactant and the product side. I have 1 sulfur, so 1 sulfur with H2SO4. I have total 6 hydrogen, 2 hydrogen with H2SO4 and 4 hydrogen with water. So 2 plus 4, 6. Then I have 6 nitrogen atoms. So 6 nitrogen atoms are present on product side with 6 NO2. Now 6 is a 18 oxygen atom. So I have 4 oxygen atom with sulfuric acid on product side. 6 2s are 12 oxygen atom present with NO2 and 2 oxygen atoms are present with water. So I have 4 oxygen with H2SO4, 12 oxygen with NO2. So 4 plus 12, 16 and 16 plus 2, 18. So also here I have number of atoms are equal on the reactant and the product side. So this equation is balanced equation. This equation is also balanced equation. Now let me take one more example. That is, we have copper plus HNO3. This is very interesting example. So this is our fourth example to study. So copper plus HNO3. This is dilute HNO3 we have. It will give me CuNO3 twice plus nitric oxide, colorless gas, plus water vapor. So as our usual job, we assume a coefficient. So let me have some coefficient here as a A, here as a B, here as a C, here as a D, and here as a E. Now my job is to find the values of this coefficient. So first, as usual, I start with copper. So copper, I have A is equal to C. Then second element I'm having hydrogen. So H is equal to B and that is equal to 2E. That is equal to 2E. Third element I'm having nitrogen. So nitrogen is equal to B. That is equal to 2C plus D. Okay. And then fourth element I'm having, that is oxygen atom. So 3 into B. So I have 3B is equal to 3 to the 6C. So I'll be having here 6C plus D into O. So I'll write D here and plus E. Okay. Now let once again assume B is equal to 1. Let B is equal to 1. So if I assume B is equal to 1, I'll get 1 is equal to 2E. So E is equal to 1 upon 2 I'll be getting. Then I have 1 is equal to 2C plus D. So I have 1 minus 2C is equal to D. Now substituting these values of B, E and D in this equation, that is 3B is equal to 6C plus D plus E. So 3B value I have 1 is equal to 6C. C value I don't know, plus B value, I just got here 1 minus 2C, and E value, I got it as in 1 upon 2. So I have here 3 is equal to 6C. Okay, here I'll take common LCM. So 1, 1, let us take a common LCM here, that is 2, 2. So here I'll be having a value like this way, another. Okay, so I have here 6 is equal to 12C plus 2 minus 4C plus 1. So I have a 6 here as it is, 12C minus 4C, that is 8C plus 3. So C value, I'll get it as in 3 upon 8. Now as A and C are equal, so C value I got it 3 upon 8. So A value also I'll get it as in 3 upon 8. Okay. Now further moving towards calculating the value of D. So let me calculate the value of D here. I have D is equal to 1 minus 2C. So it is 1 minus 2C, C value 3 upon 8. Okay, so that is 8 minus 3 upon 8. So this I'll be getting as 8 minus 2C. Here there is a 2 here. Okay, so 8 minus 6 upon 8 will come. Let me rectify this again. So 1 minus 2 into 3 upon 8. So it is 8 minus 6 upon 8. So 8 minus 6, 2 upon 8. I'll get 1 upon 4. Okay. So D value I got it as in 1 upon 4. Now let us substitute the values. I have ACU. So A value I got it as in 3 upon 8 Cu, plus B value I got it as in 1 upon 1 HNO3, which will give me ABC. See, once again 3 upon 8 CuNO3 twice, plus D value, that is 1 upon 4 NO, and E value as an H2O. So E value I got it as an half H2O. Okay. Now if you look at here the common LCM which is present, that is 8. So here I'll multiply by 8, here I'll multiply by 1, here I'll multiply by 2, and here I'll multiply by 4, and this by 1. Okay, in order to get common LCM. Now 3 into 1, I have 3 Cu, plus 1 into 8, that is 8 HNO3, which will give me 3 into 1 3 CuNO3 twice, plus 2NO, plus 4 H2O, because 4 into 1. Now let us check the number of atoms on the product and the reactant side. I have 3 copper on reactant side, 3 copper on product side. I have 8 hydrogen on reactant side, 8 hydrogen on product side. I have 8 nitrogen on reactant side. Here I have 2 3s are 6 nitrogen with 3 CuNO3 twice and 2 with NO. So this is 6 plus 2, 8 nitrogen. 8 3s are 24 oxygen. 8 3s are 24 oxygen on reactant side. So I have 3 2s are 6, 6 2s are 18 oxygen with 3 CuNO3 twice, 2 oxygen here. So 20, and 20 plus 4, 24. So here also this equation is balanced. Hope you must have understood this method. One recommendation, do practice this equations number of times like this method so that you won't face difficulty in balancing equation. Thank you for watching.